Oh, welcome to my new video. Our today's question is swim in rising water. This question is of graph, okay, standard graph problem, and I'm going to solve this question by using binary search. So let's start the question. Before that, if you are new to the channel, make sure to hit the subscribe button. So you are given an n cross n integer matrix grid where each value grid of ij represent the elevation at the point. Okay, these all are the elevations, means height, and the range from this is the grid of the heights. Elevations are ranged from 0 to n square minus 1 because this is less than. Okay, so for this n is pi, means heights or elevations can be from 0 to 24. Okay, n square means 25, minus 1 is 24. Yes, the smallest value is 0 and the largest value is 24. This is very key observation. Okay, these values are very important. Why? Let me explain you. Like after that it starts raining and the water gradually rises over a time. At time t, the water level is t, means at time t means time equal to 10, the height of the water, okay, is t. Okay, is 10, meaning any cell with elevation less than or equal to 2 is submerged or reachable. Let me explain. Means like if time is equal to 10, okay, that means any buildings like this height is 1 2 4 5, the water level is 10, means we can reach any. Okay, the water level is 10, but all the buildings are submerged, and then we can simply move from this building to this, even if this height is greater than, but we can swim. Okay, this is the main point, okay, of this question, and this is the main point. Okay, and why our elevations are very important, like why I told you the minimum and maximum value, because let's see, the maximum height is 24, means at time t, the at time 24 all heights are, all elevations are submerged. That means we can move in any direction. Okay, now you can swim from a square to another four directional adjacent square, means from any cell you can go to four direction, left, right, up and down. Okay, if the elevation of both square individually are at most t, that means, let me explain you. Means okay, if this is height is 4 and this height is 5 and time is equal to 6, the water level is this. Okay, so you can move to this cell to this cell. Okay, means if time is equal to 16 and you are on this cell, so you can move to 15 because both cells are submerged, both elevations are submerged. From 14 you can also go to 13, you can't go 22 because our time is 16. Okay, so this is they wanted to tell us, and this is the main key observation. Okay, and you can swim infinite distance in zero time. Okay, let me show. Like in this example you can go from 0 to 6 in 0 second if the time is 16. Okay, of course you must stay within the boundaries. Okay, so you have to stay in the boundaries. Also return the minimum time until you can reach the bottom right corner, means from 0 comma 0. So you have to return the minimum time. I already told you the maximum time. Maximum time is maximum elevation. Time is 24. At time 24 you can reach any cell. Okay, so we have to return the minimum. If you start from this index 0 comma 0, okay, this coordinate to last cell. Okay, so let me explain you the question. Question is very tough, but this is the standard DFS algorithm question, so that's why this is simple. Okay, so maximum height and minimum height. So minimum height is 0, maximum elevation height is, means elevation, okay, is 24, n square minus 1. Okay, so what can be the time? Like maximum time is 24. Okay, this is the maximum time. At t is equal to 24 we can reach any cell, and at t is equal to t min is equal to 0. Okay, so the time can be from 0 to 24. Okay, this is the range of our time. So we can simply traverse DFS, but with one condition. One condition is time. Okay, so if we give the DFS three things: the x value, y value and time t. X, y means their coordinates. Okay, so it will return us, just assume that this function will return us if we give him coordinates and time. Okay, so it will return us if we can reach from 0 to this cell, okay, by taking any path, the last cell, so it will return us true. Okay, how? Let me tell you. If time is equal to, let's see, 18. Okay, time is 18 and we are doing DFS on our first cell. Okay, it will return us if we can able to reach here or not. Okay, so from 0 we have 4 directions: up, back, forward and down. Okay, so these are invalid. So can we reach to 1? Yes, we can reach, because both the cells are elevations are less than our water level. Means this is the height 0, this is height 1, and our water level is 18. So both are submerged, so we can simply swim and go. Okay, so we can reach 1, we can reach 2, we can reach 3, 4, 5. We can't go to 21 because 21 is greater than our elevation. Okay, we can go 16 because both heights are less than 18. Then we can go 15, then we can go 14. From 14 we can go 18, less than or equal to. Okay, this is given in the question. After that we can go 8, we can go 7, then 7 to 6, and then we can, okay, then we are reach our destination, so it will return us a true. Okay, I am going to explain in the coding part how we can implement our DFS algorithm. DFS algorithm is standard DFS algorithm, but with one check. Can we, like, from 0 to 1, if time, like, both heights has to be less than our time. Okay, time means water level. Okay, now we can simply do one thing. We can pass our DFS algorithm. Our DFS algorithm will take our x, y value and time value, so it will return us true if we can reach to the last cell. Okay, so we can pass 0 comma 0, and the third value is from 0 to 24. We can pass all the values and it will check if it is possible. At 15 we can, like, if time is equal to 15, we can go 1, then 2, then 3, 4, but we stuck here. We can't go 16 and we can't go 24. It will return us false. But at time is equal to 16, this is answer. Okay, this is also answer of this question, this example. As time is equal to 16, okay, we can reach. How? By showing the given path. Okay, this is the path. We can simply go and reach our destination, so it will return us true, and we can simply return our 16 answer. But we can use binary search. Why? Very simple. We can use binary search, because let me show you. Like, let's take the binary search. Okay, what is the mid value? Low minus high. This is the low, this is the high. Low min Okay, low minus high by 2, this is 12. Okay, can it is valid for 12? No. Why? Because we can go till 5, but from 5 we can't go to any direction, so it will return as a true. That means from 0 to 11, for time is equal to 0 to 12, everything is invalid, because 12 is greater than 0 to 11. If it is invalid, that means the time is less than 12. Okay, so for less time it is not going to valid. If 12 is greater, it is still invalid. That means from 0 to 11 everything is invalid. So we can change our minimum time value to increase, and it is mid plus 1, that is 13. Now again calculate our mid. Mid is 12, 24 plus 13. 24 plus 13 divided by 2 is 18. 18. Okay, 18. Let's try for 18. Okay, from 0 we can go 4, 5, 16, 15, 14 and 18. Okay, it is valid. Okay, it is valid. So our DFS algorithm returns as a true. So we can simply store our answer here. Okay, our answer is 18. Now if it is valid for 18, then it is going to valid for 18 to 24. Okay, for time t it is valid. So for time t plus 1 it is also going to valid. So we can change our high value, this high value or time max value, to mid minus 1, because we already calculated our mid. Okay, our answer. Okay, now what is the mid? 17 plus 13 divided by 2 is 15. Okay, can it is valid for 15? No, it is not going to valid for 15. It is going to stuck here. Okay, so what we can do, we can simply, like, for 50, if it is valid for invalid for 15, that means from 0 to 15 it is invalid. Okay, like for t it is invalid. So for t minus 1, like for t minus 1, like for t minus 1 it is also going to invalid. Okay, so let's change our minimum value to mid plus 1. Okay, we have to increase our time. Okay, we have to increase our time. This is 16. Okay, so now what is the mid? Like 17 plus 16 divided by 2, 33 divided by 2 is 16. So our mid is 16. Okay, so our mid is 16. Can it is valid for 16? Let's check. Okay, our answer is 18. Okay, our answer is 18. yes, it is valid for 16. We can reach like that. Okay, our DFS algorithm returns us a true. That means this is valid. Okay, for 16 it is a valid. So we can simply change our answer to 16. Okay, now we have to change our high value. It is valid for 16 to 24. Okay, so we can change our high value to mid minus 1, and that is 15. So now we can simply stop, because we calculated for t equal to 0 to 16, and also t is equal to 24 to 15. Okay, we already calculate for every possible value, and we can simply return our answer, that is 16. Okay, now let me show you the code. Okay, so I already write some values. Okay, this is n length. Okay, and this is answer, the max value. So we have to return the minimum, so I take integer max value. At the end we have to return our answer. So we are doing the DFS, so we have to go in all four directions. These are the all four directions, mean the row is same, but column minus means we are going back, front, up and down. Okay, so we have to simply add this value in x coordinate, this value in y coordinate, to get our neighbors. Okay, so now let's do. So what is our low value? Means time minimum value. Time minimum value is 0. And what is our high value? High means time maximum. Maximum time, how much we need? The maximum elevation, and maximum elevation is n square minus 1. N square minus 1. Okay, now we have to run a loop. Okay, like low is less than equal to high. Okay, this is high. Now we have to calculate our mid value. Mid value is nothing but high plus low, low plus high divided by 2. Okay, this is our mid value. Okay, now after that what we need to do? We have to check. Okay, if, and also we have to check, like if we can go our like grid of 0 comma 0, like this index is this elevation is also less than or equal to our time. Okay, and this is our mid is our possible time, possible answer. So we have to check also for grid of 0 comma 0, this is also less than or equal to our mid value. Okay, why? This like mid is possible time value. Okay, this can be time. Okay, so if this value is 10 and we are at time 2, so we can't go there. Okay, for now this is 0, so we can go, but this also has to be less than or equal to our time. So we have to check that also, and after that we have to check also one condition, like DFS we are passing index. Okay, we are going from 0 comma 0 to mid, this is time. Okay, this is the possible time value, comma we have to pass our grid and boolean array, boolean visited array. So first we have to create our visited array, this is the boolean. So we are doing the DFS algorithm traversal. Okay, visited of new int of n, so new boolean, sorry. Okay, boolean of n comma n. Okay, and if this returns us true, that means we can reach the last index. So we can simply say, if this is the valid, that means every value bigger than that is value is valid. So our answer is mid, this is the possible value, and we have to now high value is mid minus 1. Let me explain why I write this. Okay, if our t is 18, that means it is valid. If we can reach from, okay, this is valid, that means for t is equal to 18 to 24, everything is valid. Okay, so we have to decrease the value. Okay, because we want minimum time, so we are just changing our high value to mid minus 1, that is 18 minus 1 to 17. Okay, this is what we do in the my research. Otherwise for t, if it is invalid, that means we have to increase the time. Okay, that means we have to increase our low value to mid plus 1. Okay, if it is invalid for t is equal to, okay, t, okay, then we have to increase the time. Very simple. Okay, and now we have to do our DFS traversal. Okay, so we have to simply x comma y, we have to write true. Okay, we have to write true, and after that also when we reach this cell, that means if okay, let me explain you afterwards. Okay, then we have to go in four directions. Okay, in I equal to 0, I less than 4, I plus plus. So what is our new coordinates? New like new x is nothing but x plus d I r s directions of 0, okay, directions of I and 0. This is x, this is for row, and for new our this is no, okay, new x, okay, new x coordinate, new y coordinate is nothing but our current y plus directions of this, and this is nothing but store in first index. Okay, so we get our new coordinates. Okay, now we have to check if it is valid. That means it has to be stay in our grid. Okay, so we have to check also that, like, new x has to be greater than equal to 0, new x has to be less than our n, also new y has to be greater than equal to 0, new y is less than equal to n. After that we have to also check, like, visited of new x comma new y. If we already calculated that, we don't care. Okay, if it is equal to false, that means we don't calculated it, so we can proceed. Okay, this is the main condition. Okay, now what we have a time. Okay, so the both, like, if we are traversing from 0 to 1 at time 10, so the neighbor elevation has to be less than or equal to our time. Okay, time t. Okay, our, so we have to that check also. Okay, so grid of new x comma new y has to be less than or equal to our time. Okay, if this is true, that means we have to return, like, if our DFS new x comma new y for time t grid comma visited array, if this returns as a true, and when it returns true, it returns true when our x coordinates, like, we reach our n minus 1 row and n minus 1 column. Okay, when it's reached n minus 1 row and n minus 1 column, so we have to simply check if our x is equal to n minus 1 and our y is equal to n minus 1. If we reached our destination last cell, so we can simply return true. Okay, by traversing in all four directions, if we are able to reach the last index, okay, last cell means this cell, so we can simply return true. If this returns true, we can simply return true. Okay, otherwise, by traversing in every four directions, we are not able to reach 6 at time t, so we can simply return false. That means we have to increase our time value, so we increased our time. Low means lowest time. Okay, so we have to increase our time. So let's try to run it. Okay, what they're saying? Okay, we have to write one here. Okay, semicolon missing. So if you are new to the channel, make sure to like, share and subscribe. It is running. Let's try to submit it. If you are new to the channel, make sure to like, share and subscribe, and also if you have any doubt, make sure to comment. I am going to answer you. Okay, thank you so much for watching.